I'm Nicole Payton. This is Colin, special guest lecturer today. This is my fifth attempt to try to do something. Apparently the microphone on my computer is awful. So we're going to try this. Hopefully we'll make it through without too much disturbance. So I read the effects of engineering modules on student learning in middle school classrooms. This was about a pilot program done at the through the University of Nevada in Reno, and it was professors from the College of Education getting together with professors of the College of Engineering at the university and creating this Teachers Integrating Engineering into Science program. What that did was it paired university faculty with middle school science teachers to create units to include engineering design. It was 4 districts and 8 teachers, so it was notably a pretty small study, a pretty small program. At this time, this is 2004, so pre-NGSS, and there weren't any engineering standards involved in the science curriculum or state standards at that point. So what the teachers did was they created units, and the units were standardized. It was 8th grade, they were all 8th grade science, which is what I teach. And they included a web-based simulation lesson, lesson plans, a design project, and 3 types of assessments. And they were comparing them to the 8th grade state's science standardized test, was what they were comparing the scores to. And as I said, at this point, there were no engineering topics addressed in the K-12 standards. But there was already research showing that design challenges engaged students in the engineering enterprise, and so that was sort of what facilitated them to start this study. The teachers worked in teams, and they formatted sort of a standardized modules that focused on science topics aligned with the state standards and the curriculum. Oh, maybe I'll get a break. Hey, here was our guest speaker. One of the most important components was the web-based simulation, and this was actually developed by the teachers, since there were some web-based math and science things available, but there were very few directly related to engineering design. They wanted to create their own simulations, so the teachers storyboarded it, and then they hired professional developers to come in and develop the lessons. They also developed their own sort of simplified learning model that they called the triangulated triangulated learning model, and that was a compilation of the 5 E's, which you're probably familiar with, and the Kolb model. The major difference was that the driving questions focused less on content and more on how to make a system work. It was iterative, required evidence, explanation, and connections to knowledge and content. All the teachers were trained in the engineering design process skills, and they included these as teaching strategies within this triangulated learning model, which is sort of reminded me of the science and engineering practices, which we include now with NGSS. So the results of the study were interesting for 2 reasons. One was it closed achievement gaps in expected places, especially with the design project module, or the design project assessments with special education students who I teach, as well as Black and Hispanics. So it's not surprising that the achievement gap, when they were allowed to do these design projects and do a performance-based assessment, the achievement gap was significantly decreased. However, it was increased with females compared to males. When they compared it to just the pen and paper assessment, there was not that much of a gap between male and female content knowledge, but when it became to this performance-based assessment, females did not as well. So they thought that there definitely needed to be some further study into this and what the cause might be. But overall, all of the teachers reported more engagement, and that they felt that this model sort of helped develop science concept knowledge and higher order level thinking skills. Now I hope I can upload this.